Hello students, this is Sir Ronnie Banan, and for this session, I will be discussing to you all about kites. So you should be able to identify the properties of kites and apply the properties in solving problems. So let's move on. What is a kite? A kite is a quadrilateral with two distinct pairs of adjacent congruent sides. So consider this diagram, KITE. So the first pair would be this and this. So we say line segment KI here is congruent to line segment KE. KE. That is the first pair because we need two pairs. And the second pair would be this and this. So we say line segment TI is congruent to line segment TE. And we now have two pairs, so therefore it is a kite. Let's move on to its properties. The first property, it states that one pair of opposite angles are congruent. We need only one pair of opposite angles to be congruent. So look at this. So we have angle E and angle I, which are opposite angles, and they are congruent. So we say angle E is congruent to angle I. You know, E here, or angle E, can be named also as angle KET, and also this angle I here can also be named as angle KIT or TIK. Okay? So the second property states that the diagonals are perpendicular. So look at this diagram. First diagonal, second diagonal. Now, we say that line segment KT, which is the first diagonal, is perpendicular to line segment EI, the other diagonal. And since they are perpendicular to each other, they form a right angle, or simply 90 degrees. And the next property states that one diagonal bisects the other diagonal. When we say bisects, it divides the other diagonal into two equal parts. So we have, let's say, diagonal KT bisects diagonal EI. Let's say they meet at S. So EI, or I mean line segment EI, is bisected, and therefore we have two congruent parts, line segment ES and line segment IS, which are congruent. And the fourth property states that one diagonal bisects a pair of opposite angles. Look at this diagram. This diagonal here bisects a pair of opposite angles, and these angles are K and T. So this angle K here will form two congruent angles, and these are this and this. So we say angle EKT is congruent to angle IKT. And also this angle T here is also bisected. So we expect that this angle here is also congruent here. So we say line segment ETK is congruent to angle ITK. That is the fourth property. So now, let's summarize the properties of a kite. It's a kite because we have two pairs of distinct adjacent sides congruent. The first pair and the second pair. Now, the first property states that one pair of opposite angles are congruent. There's only one pair, and these are angle E and angle I. You have to remember that you can name this angle here as angle KET or TEK, and this angle here I can also be named as angle KIT or TIK. The next property states that the diagonals are perpendicular. So diagonal KT or line segment KT is perpendicular to line segment EI. And since they are perpendicular to each other, they form a right angle. And the next property states that one diagonal bisects the other diagonal, which means that this diagonal KT divides this diagonal EI into two equal parts. Let's say they meet at S. So we say line segment ES is congruent to line segment IS. And the fourth property states that one diagonal bisects a pair of opposite angles. These angles are K and T. They are being bisected by this diagonal line segment KT. So we can say that this angle here and this angle here are congruent. So angle EKS or EKT is congruent to angle IKT or IKS. And also this angle T here, we have angle ETS or angle ETK is congruent to angle ITS or angle ITK. Did you get it? If yes, let's try an example. In kite JKLM, so we know that in the given, we have JK equals 5 centimeters. Oh, okay, so let's say the two diagonals meet at N. So JK now is 5 centimeters and LM is 10 centimeters. And KM is 8 centimeters. KM is 8 centimeters. So since um, diagonal JL bisected diagonal KM, so it's expected that we can form two congruent parts here. We have line segment KN and line segment MN. Since this is 8, we can have 4 for each segment. So now we try to find JL. JL. But how can we do that? Now since they form right triangles, we can always apply Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the two legs. Now, in my right triangle JNK, the hypotenuse is 5, and one leg is 4, and the other leg is missing. So let's say that is A. So we can have C is the hypotenuse of 5. So A is missing, and the value of B is 4. So A, B, C. So we have the square of 5 is 25, and the square of 4 is 16. So by algebraic manipulation, we have A squared equals 25 minus 16. Simplifying it further, we have A squared equals 9. So extracting the square root, we have A equals 3. We ignore the negative sign or the negative 1 because there's no such negative distance. So therefore, we can say that line segment JN is equal to 3 centimeters. How about this segment here? So it's also a right triangle, MNL. So we can have this. Let's say this is B. So applying the same concept, C squared equals A squared plus B squared. Our A is 4 centimeters, our B is missing, and our C is the hypotenuse, 10. So we have, by substitution, we have 10 squared equals 4 squared plus B squared. So the square of 10 is 100, and the square of 4 is 16, and plus B squared. So by algebraic manipulation, we have B squared equals 100 minus 16. Simplifying that, we have B squared equals 84. Now, unlike this, 9 is a perfect square number, but 84 is not. So, we have to apply the rule on radicals. So, extracting the square root, we could have this. 84 can be written as 4 times 21 because 4 is a perfect square number and its square root is 2. So therefore, my final answer would be 2 the square root of 21. So therefore, we can say that line segment LN here is equal to 2 the square root of 21 centimeters. So we now have A and B. So adding that, we could have line segment JL equals line segment JN plus line segment NL. So we have 3 plus 2 the square root of 21 centimeters. And that is our final answer because we cannot add them because the other one is not a radical. Thank you, and I hope you learned something.